Hello engineers, welcome to the new video of the course, and in this particular video we are going to see that what exactly is a current. So I know most of the guys what they know is that when we apply certain voltage, again we have not seen what exactly is a voltage. Let's say if there is certain resistor, again we have not seen what exactly is a resistor. I'm just explaining you what most of the guys know. So when we see this kind of setup, there is certain amount of current that flows from, let's say, point A to point B, alright, something like this, right? So this is the current that flows in this particular direction, right? But they really don't know what exactly is the current, right? And in the today's video or in this particular session, we are just going to understand that what exactly is the current. Okay, so for that, let's try to understand this particular analogy. Let's say I have fixed the north pole. Okay, let's say this is my north pole of the magnet. These are the two magnets, north pole and south pole. Okay, I have fixed the north pole, so the north pole is fixed. Let me just write over here this particular north pole, it is completely fixed, whereas south pole is free, it is movable, right? Now as I take this particular south pole closer to this particular north pole, what will I see? Obviously I won't be able to see this particular magnetic field, but if I try to move north pole and south pole somehow, so I can experience certain force. So that is what? That is nothing but magnetic field. I hope you all guys have experienced this force, right? Whenever you try to put two magnets closer to each other. So this is what? This is my magnetic field. Magnetic field. Okay. Let's say if I am trying to bring this particular south pole closer and closer to this particular north pole, what is going to happen? Obviously they'll get attached, right? Something like this. So what I can say, the magnetic field has increased, okay, as I'm moving the south pole closer to this particular north pole. Okay, I hope you are able to understand this. So this was a small analogy. Well, we are going to use this particular analogy to understand the concept of current. You will be able to understand this, don't worry about that. I hope you understood this basic analogy, the simple analogy what we saw. The north pole is fixed, so the south pole is movable, right? As I am bringing south pole closer to north pole, due to the magnetic field or due to the attraction, the south pole gets attached with the north pole. Okay, now let's try to understand in terms of electric or charge, okay, or electricity. So obviously electricity is nothing but flow of electrons. Okay, electricity is nothing but flow of electrons. We will see that, don't worry about that as well. Now if directly I would have jumped onto this particular concept, then it would have been pretty difficult for you guys to understand this particular concept. So that's why I took this particular analogy of north pole and south pole. Now you will be able to understand this particular concept, right? So let's say I have positive charge and I have negative charge. So obviously they will be experiencing certain force, okay, due to what? Due to the electric field. Okay, in earlier case we had magnets, due to which we experience the magnetic field. Okay, but now we have two charges, right? Treat positive charge as north pole, negative charge as south pole, due to which an electric field is generated, and we can actually, I mean, not we as in we are going to really experiencing the electric field, because charges are very, very small. We cannot even see them, right? Okay, but since we cannot see them, what we are doing, we are applying the same analogy over here. What we are doing, we are bringing two charges, one positive and one negative, close to each other. Okay, so what I see is that as the charges come closer to each other, an electric field is generated, right? I hope you are able to understand this, right? This electric field is generated as I am bringing negative charge closer to the positive charge. Also there is one more thing, and that is only electron moves, only negative charge moves towards the positive charge. That is, positive charge is stationary, right? Because in our case as well, if you see, the north pole was stationary, right? So I'll just write over here, only negative charge, write it in this way, only negative charge, that is electron moves. Okay, I know this might sound a little confusing as of now, like what exactly is happening or what I am discussing, but believe me, as we move further and further, this will be pretty easier for you to understand. As of now, you just make sure that you are completely focusing onto this particular topic. What we saw this particular analogy where we had done where we have fixed the north pole of the magnet, we are bringing south pole closer to the north pole. Magnetic field is generated, and thus at the end eventually the south pole gets attracted towards the north pole and it gets completely attached with the north pole. I'm not attaching it as of now. Okay. In the similar manner, when we deal with charges, right, treat north pole as the positive charge, south pole as the negative charge, and electric field is generated whenever we are trying to bring these two charges closer to each other, right? But over here as well the concept remains the same. I'll show it in this way so that you should not get confused. So the positive charge it did not move, whereas the negative charge it moved towards the positive charge, right, due to the electric field. Okay, only negative charge, that is electron, moves. I hope you are able to understood this particular thing. Okay, now let's move further. I know I have left this particular discussion as it is incomplete. We'll see that, don't worry about that. Alright, so now let's do some small experiment. Okay, so let's assume that this is the conductor. Okay, and inside the conductor we have certain atoms. I have just shown 3 atoms, and obviously I have shown certain distance, so that whatever the concept that I will be explaining over here, so that becomes pretty clear to you all guys. Okay, and these are charges. Let's assume this is highly positive charge and this is highly negative charge. This is the conductor, and obviously conductor has certain atoms, and as we had already seen, the outermost electrons are loosely bound in case of conductors, right? So even by providing certain energy to those particular electrons, we can extract those particular electrons out of those particular atoms, right? Okay, I hope you all guys know all of these things which we have seen in the previous session. So let's proceed further. Alright, so now what I'm doing is, so what I'm doing is that I have connected this positive charge to the conductor and have also connected this negative charge to the conductor. Okay, I hope you are able to understand this. Great. Now what I see is that the moment I connect this negative charge, a highly negative charge, to a conductor, right, so the electron present over here in this atom, it will come out. Why? Due to the repulsion of this particular negative charge. Okay, also if you see this particular negative charge, it will provide certain electron. Okay, it will provide certain electron. The negative charge has what? A high amount of electrons in it, a high amount of electrons. Let's say it has thousands or crores of electrons or lakhs of electrons in it, right? Millions or trillions of electrons in it. So it will emit few electrons, right? Okay, I'll just write E. I won't show the negative sign. Yeah. Okay, so we were over here. So now what is going to happen? So this electron, it came out of this particular atom, right? And then this electron will start repelling this particular electron. Alright, this electron which got extracted from atom 1, it will repel this electron which is present in atom 2, right? And due to the repulsion, what is going to happen? Due to the repulsion, this particular electron, it comes out. I hope you are able to understand this. Okay, now what will happen? The moment this particular electron comes out, the electron which was extracted from the atom 1, it will take its place. Okay, it will take its place. Okay, whereas the electron which is being supplied by this negative charge, it will come over here and then it will take the place of the electron. It will take the place of the electron which was present over here, right? I hope you are able to understand this, guys, right? Similarly, you see this particular electron which is present over here, it will repel this particular electron. One sec. Yeah, it will repel this particular electron. Okay, the moment it starts repelling, this electron gets extracted. Why? Because there is positive charge over here, due to which it gets attracted towards the positive charge, and then this particular electron will take the place of this one, right? So what we can see in this entire scenario, the electrons are shifting one after another, something like this. This electron was present over here, it got shifted over here, this electron got shifted over here, and then eventually this electron came out and it is present over here, right? Okay, whereas this negative charge, it will keep on supplying certain electrons. I hope you are able to understand this entire phenomena. Okay, so what we can see over here, let's take another diagram and let's try to understand it once again. As I clearly mentioned, this negative charge will provide certain electron. Okay, Now you just need to focus over here what exactly is happening. This negative charge, it will repel this particular electron, so this electron will come out. Okay, the moment this particular electron comes out, what we can say, this atom gains certain positivity. Okay, this atom gains certain positivity. This atom gains certain positivity. I'll just show it in this way. Yeah, this atom gains certain positivity. I'll show it over here. Yeah, this atom gains certain positivity. Okay, why? Because as of now it is free by one electron, right? And then what exactly happens? This electron which was present over here, it will repel this particular electron. Okay, it will repel this particular electron, and due to the repulsion and the attraction of the positive charge, this electron will come out. Okay, and simultaneously this electron which was present over here, which was supplied by the negative charge, it will fill this particular space. The moment it fills this particular space, the positivity of the atom vanishes. Whereas if you see this particular atom, now it becomes positive, because as of now it does not have any electron in its outermost shell, right? So this atom is kind of positive, right? I hope you are able to understand this, right? Okay, and now what happens? You see this particular electron which was present over here, now it will accommodate this particular space. Okay, the space left by this particular electron, right? And due to which this atom becomes neutral, right? Now you see this particular electron, it will try to repel this one, and due to the repulsion and the attraction of this particular charge, this electron comes out. Okay, the moment this comes out, this atom becomes positively charged, right? Positively charged. Okay, after that this particular electron, it comes over here and takes this place of this particular electron, and the positivity of this particular atom vanishes, or this atom becomes neutral. So what we saw in this entire discussion, you see this particular electron, I'll just move over here. You see this particular electron, I'll just take all of the electrons out. First thing is this, that is this electron moves in this way, that is one after another. It jumps from one atom to another, something like this. Okay, and secondly what we saw is the direction of the electrons. So all of these particular electrons, they are moving in this particular direction. Okay, they are moving in this particular direction. Whereas you see the positive charge which was developed, okay, as such there wasn't any charge, right? It's just the thing is that the atom was the atom was bit of positive, right? I hope you are able to understand this. The atom was bit of positive. Okay, there wasn't any such positive charge. Okay, I hope you are able to understand this. But if I consider this as a positive charge for a moment, what we can say, it was moving in this particular direction. Okay, this positive charge which this atom gained, it was moving in this particular direction. Okay, I hope you are able to understand this concept. Okay, the electron was moving from one atom to another. As soon as the electron left this atom gained the positive charge. Similarly, as soon as the electron from this atom left, this atom gained positive charge, and so on, right? So the flow of the positive charge is known as current. As such, this is not the exact definition. I'll come to that particular point, don't worry about that. Okay, so this flow of charge is known as current, right? Flow of positive charge. Again, this is not a charge, I have just explained you so that the concept will be crystal clear. This is not the exact definition of current. Because what happens is that most of the books, they will confuse you with electrons. They will say that this is the direction of current. Few of the books, they will say that this is the direction of the current. You should not get confused. Just remember one point, current always flows from positive to negative. Okay, we have not yet covered the definition of current. I'm just explaining you the direction of the current. Okay, I have seen most of the students and most of the books, they say that, you know, the electron flows in this particular direction, that is from negative to positive, so this should be the direction of current. Okay, wrong, this is the direction of current. Okay, like this is the conventional current. I'll show that, don't worry about that. We'll see that, don't worry about that. So just remember, current always flow from positive to negative direction. Positive to negative direction. Okay, so this is the positive charge. You can take it as voltage. If you know what exactly is the voltage, that's fine. You can treat it as plus 5 volts and this as minus 5 volts, right? Okay, so you see current will always flow from plus 5 volts to minus 5 volts. If you don't know what exactly is the voltage, that's fine. You can treat it as a positive charge. Okay, so my current will flow from plus 5 to minus 5. As of now, you just focus upon the direction, right? Now the point to notice over here is that if you could remember the discussion over here I had which I left partially over here, I clearly mentioned that over here only electrons are moving, right? The positive charge are stationary. And if you see over here what exactly is happening, the electrons are moving, and as the electrons are moving, the atom is getting certain positivity, right? So to us, if we'll now look at the entire scenario, to us it looks as if the positive charges are moving in this particular direction, but no, the electrons are moving in this particular direction. And since the electrons are moving in this particular direction, to us it seems that the positive charges are also moving in the opposite direction of electron. I hope now you are able to understand this particular point. Again, I'll just repeat. Over here I clearly mentioned that the positive charge will remain stationary, only the negative charge will move, right? Okay, you see over here in this entire scenario, the electrons are only moving, right? The electrons are jumping from one atom to another and so on, right? And as the electrons are jumping from one atom to another, it is making the this particular atom, or making the atom positive for certain time interval, right? So to us this positive atom looks as if it is a positive charge moving from, let's say, moving from left to right, right? To us it looks like the positive charge, it is moving from left to right, but no, there isn't any such concept of positive charge. In reality it is the electron which moves from right to left, and due to which the positivity of the atom is being generated. I hope you are able to understand this particular entire scenario. Okay, and that's why I clearly mentioned in the starting itself that the north pole is constant. That means the positive charge is fixed, that is constant, right? It is the electron which moves, right, due to some electric field. And over here you can clearly look that the electrons are jumping from one atom to another, due to which the atoms are gaining certain positivity. Okay, so that means what? That means the current is generated. Okay, current is generated. This is not exactly a current or exact definition of current. Okay, so please don't take this as a definition of current. I'm just explaining you the direction first. We'll see the definition after some point. Don't worry about that. Okay, so remember, as I clearly mentioned, current always flows from positive to negative terminal of battery, or positive voltage to negative voltage. Okay, since I have not explained yet what exactly is the voltage, so intentionally I have written it as positive to negative. Okay, positive supply to negative supply, whatever you want to write. Okay, just remember this particular point. Current will always flow in this particular direction, I. Okay, so I'll just show it to you over here. So this will be the direction of current, I. Okay, so this will be the direction of current, and current is denoted by I. We'll see that, don't worry about it. Okay, I hope you understood the direction of current, right? Let's proceed further. Yeah, and as I clearly mentioned, current always flows from positive to negative. So positive charge or positive voltage, it acts as what? Higher potential. Higher potential. And this negative voltage or the negative charge, it acts as the lower potential. Okay, lower potential. Similarly, if you see, if in this dam, this particular point, it acts as the higher potential. Yeah, this particular point, see this one, this particular point, it acts as the higher potential. Right, because water always flows from higher potential to lower potential, and this entire area, this acts as the lower potential, right? Lower potential. And what we know is that water always flows from higher potential to lower potential. Water will never ever flow in this particular direction, right? It will never ever flow in this particular direction. It will always flow in this direction, that is from higher potential to lower potential, right? Okay, so make sure that whenever you are learning a current, treat the current as the water. Okay, so that it becomes pretty easier for you all guys to understand this entire scenario. Okay, so let's proceed further and let's try to understand that what exactly is a current. So over here I had mentioned the definition, that is number of charge moving from a cross sectional area per unit time is known as current. This looks pretty difficult. No worries, I'll make it pretty easy for you all guys. As I had clearly mentioned that you assume current as the water analogy, right? So over here you just assume current as rate of flow of water. Rate of flow of water. Okay, so let's assume that this is a river, as you can clearly look over here, and let's say I'm taking this area, small area. Let's say this is the area that I'm considering. Let's say this is my point A, this is my point B. Okay, and let's say 10 liter of water, I'll change the color. Yeah, 10 liter of water it is entering at point A, in point A, 10 liter, and 10 liter of water it is exiting from point B, and all of the thing is happening within, let's say, 1 second. Okay, 1 second, 1 second, right? So what is the rate of flow of water? So the rate of flow of water, let's say, just write it in the short way, RFW, rate of flow of water, is nothing but 10 liter per second, right? 10 liter of water is coming and it is leaving at 1 second, right? From point A to point B, from point A to B. This is what I can write. So this entire scenario is nothing but my current, or definition of current. This is nothing but the current. Okay, no issues. We will see that once again, the overall idea. So number of charge moving from cross sectional area per unit time is known as current. So you see this is my conductor. Okay, so this is my conductor. I'm taking this cross sectional area from here to here, right? So this is the cross sectional area that I'm talking about. Okay, so I'm interested that how much amount of charge is coming and leaving from this particular area within certain time period. Let's say that time is 1 second, 2 second, I don't know, I'll take it as 1 second, right? Because generally we consider time in seconds, right? Again I'll repeat, number of charge, right? Number of charge, which is denoted by Q. Q is nothing but charge. Number of charge moving from a cross sectional area per unit time is known as current, right? What is current? Current is nothing but number of charge moving from cross sectional area per unit time is known as current. So you see this is the definition, I is equivalent to Q by T, which I had clearly mentioned over here. Okay, and its unit is C by S, because charge is nothing but coulomb, and time we generally prefer to take it in seconds, right? Okay, so I hope you understood this definition. You can relate it with this one. Again I'll just repeat over here what we saw. We just took the area of the river. Okay, from point A to point B, we saw that 10 liter of water is coming towards point A. After 1 second it is leaving. So the rate of flow of water is 10 liter per second. This entire scenario is nothing but a current, right? So just show it to you over here. Let's assume that this is my river. This is my point A to B. From point A to point B, the river takes, let's say, time is equivalent to T seconds. Okay, the flow of water, is nothing but, it's like a current I. Okay, the amount of water that is entering, amount of water entering, that is 10 liter of water. We took 10 liter, so that is nothing but my charge. Okay, so this charge, it is entering in point A, and the amount of water left at point B is how much? 10 liter, right? So again, this is my charge. Okay, so current is nothing but charge, that is amount of water divided by time it took to move from point A to point B. Simple, that's it. So this is the exact definition of current, right? And what is the direction of current? As I clearly mentioned, water always flows from higher potential to lower potential. So if I take voltage, so current will always flow from positive supply or the positive voltage to the negative voltage, right? That is the conventional current. And yeah, as I clearly mentioned, this is the definition of current. So instead of just mugging the definition, it becomes pretty easier when we try to take the help of water analogy. What is current? It is nothing but rate of flow of water. Forget about this definition, right? How much amount of water is coming and leaving in that particular given area, okay? And how much time it takes. So that exactly defines the current, right? Or the rate of flow of water. Number of charge, in our case it is amount of water moving from a cross sectional area per unit time is known as current. Simple, right? Unit is C by S, or sometimes it is, or mostly we prefer to term it as amps or ampere, right? A is nothing but coulombs per second. Okay, so next time if you hear this particular term, that is, let's say if in a circuit we say that 1 ampere of current is flowing, so what does that mean? 1 coulomb of charge is moving per second in that cross sectional area. What is 1 coulomb of charge? This 1 coulomb is nothing but, any guesses, how much amount of charge, or sorry, how much amount of electrons are present in this 1 coulomb of charge? This much amount of electron, that means 6.25 into 10 raised to 18 such electron moves from A to B. That means, let's say if I say 1 coulomb of charge moves from this particular cross sectional area in 1 second, that means 6.25 into 10 raised to 18 electron, it moves from point A to point B within a fraction of second. I hope you are able to understand this particular scenario, right? So whenever someone says 1 ampere of current, that means 6.25 into 10 raised to 18 electron moves per second from that given cross sectional area. Similarly, if someone says the current is 5 ampere, or it is nothing but 5 coulomb per second, that means what? That means 5 into 6.25 into 10 raised to 18 electron moves per second from that given cross sectional area. Getting this point? So this is how quickly a current moves, right? Or basically electron moves. And as the electron moves, okay, so therefore the current I is generated. And just remember this particular point, current always flows from positive to negative, whereas electron flows from negative to positive, which I have shown over here, okay, in great detail way. Okay, and also this, remember this particular point, I'll just highlight this particular point. Current always moves in the opposite direction of electron. Although I have shown in that particular image, what I'll do is that I'll just write that particular point over here, so that whenever you will refer my PDF, there shouldn't be any confusion in your mind. This is the most important point. Current always flow in the opposite direction of electron. Opposite direction of electron. Okay, so if my electron, as you can clearly look over here, as my electron is moving in this particular direction, the current, that is the positive charge, it will flow in this particular direction. My electron, it is flowing from right to left, but my current, it is flowing from left to right, right? You can clearly look over here, right? So I'll just show it to you. If my electrons, they are moving in this particular direction, so my current I, it will move in this particular direction, right? Or if my electrons, they are moving in this particular direction, my current I, it will move in this particular direction. Okay, great. So now I really hope that you understood each and everything about what exactly is the current, how a current is generated,